In my last qualitative lecture, I described reflection, what happens when a wave encounters a boundary, either at a closed end or an open end. Let's explore that a little bit further, however. Let's now consider what happens when a wave approaches a boundary between two different elastic media. So say a wave propagates from one spring to another. What happens in that case if the two media have slightly different properties? Okay, I'm going to demonstrate this for us in just a few moments by using two springs that are hooked together. But before I do, let me give you a basic description of what you're going to see. What you're going to see is known as transmission, by the way, if talking about a one-dimensional situation. Later on, when talking about two- and three-dimensional situations, it will be referred to as refraction. Okay, so let's say that right here is one spring, and I have an incident wave pulse that is propagating in this direction. And then right here is a second spring, like so. What I've done is I've coiled the ends of two springs together. So right here is the boundary. Well, when the energy encounters the boundary between two elastic media, most of the energy just propagates into the second spring, which is rather obvious. That is, like so. But there's also a little bit of a reflection, which then goes back in the opposite direction, like so. So right here is a little bit of a reflection, and right here propagating in this direction is a transmission. If we ignore damping, then the total amount of energy associated with the reflection plus the transmission is equal to the energy associated with the incident wave pulse. Now, notice that I've drawn a reflection here, pi radians out of phase with respect to the incident. This is assuming that this boundary here acts as being similar to a closed end. This would be the case, for example, if this spring here was a lot heavier than this one. The relative densities is actually what's important. But if this spring here was a lot heavier than this one, then the boundary can behave as a closed end. It could also behave as an open end if the reverse situation were true, but suffice to say, whenever a wave encounters a boundary between two elastic media, there's a reflection and there's a transmission. Okay, so let me quickly demonstrate this for us. I'm going to have to move my phone in order to do so. So bear with me here as I do. I'm actually going to place my phone here on the floor, like so. Actually, let me just hold it. Okay, and then I have right here a boundary between two elastic media, and now watch what happens when a wave encounters that boundary. Okay, pretty obviously, most of the energy just propagates through into the second spring. But if you watch carefully, in the first spring, you'll see a little bit of a reflection, a little ripple come back towards me. Like so. That little reflection right there, that right there is part of the energy that I originally used to create the incident wave pulse. But then most of the energy just propagates into the second spring, like so, which is usually rather obvious. Okay?